All right, guys. So in this lecture, we are going to look at the PCH201 practical, and this will be Redox Titration. Now, Redox Titration is not something that is new to any one of us. We say when we talk about Redox Titration, we are talking about reduction, oxidation, reaction, right? It's something that you guys were taught in class this semester, and I don't know. See that the question that will come will be Redox Titration, direct titration, back titration, or the one we've done before, EDTA, which is complexometric titration. That one that has EDTA is called complexometric titration. The complexometric agent there is EDTA, all right, for the previous one we did. But this one is redox titration. It involves potassium permanganate. This titration does not need indicator. Why does it not need indicator? Because potassium permanganate is a self-indicator. Potassium permanganate is what indicator? Self-indicator. Is purple in color. Then when the endpoint reach, it turns to pale pink or colorless. Purple in color. At endpoint, it changes to pale pink or colorless. Is that okay? So it does not need any indicator. Potassium permanganate is a self-indicator. Now, this experiment, this is how it usually comes out. A is a solution. Whichever way they position the question, see, the most important thing you should know is A is a solution of potassium permanganate. Know the concentration of, anyhow when they want to position the question, just know one concentration of potassium permanganate. They gave 0.1 normal. Then come the equation where they will give. What did they give? 0.2 molar is molar. So work with molarity. So you take this concentration, cycle and keep. Are you getting it? 0.02 molar potassium permanganate. Keep am for corner because you go need them. And B is a solution of ferrous sulfate. All right? Put A in the burette provided and titrate against 10 ml of solution B, which is equivalent to 0.5 gram. It means, listen, this 10 ml, they tell you say the expected weight, because now potassium permanganate now be like the standard solution. 9-day burette is the titrant. Are you getting it? Remember, I told you something about titrants earlier, Abi? Potassium permanganate now be the titrant. Now that one we know. The concentration of potassium permanganate, they give us 0.02 molar. Ferrous sulfate, now that one we dey try know. We dey try know now. We never know am. But this 10 ml normally is supposed to be 0.5 grams. So the expected weight, you can just write it at the corner. Expected weight, my dear student, you know we go use expected weight stay do percentage purity later. Expected weight is 0.5 gram. So the expected weight of ferrous sulfate is 0.5 gram. So note that the weight of ferrous sulfate when they go give is the expected weight, while the molar concentration of potassium permanganate given also take note of, and you go use them. Are you getting it now? Obtain the Titre value in triplicate and determine the mean value. Sample B was prepared in acid media. Now, take note. They say obtain the Titre value in triplicate. So let us say the Titre value. They say do them into 3 places. Let's say the first one you get 10.10 mil. Second one you get 10.20 mil. The third one you get 10.10 mil again. This is triplicate. Are you getting it? These are the Titre value. So you will get the mean Titre value, right? So my dear student, what do you think will be the mean Titre value? Based on what I've taught you, we have 10.1, 10.10 plus what? 10.2 plus 10.10. Everything divided by what? 3 will give us the mean. So my dear student, what will be the mean now? What will be the mean now? The mean will be 10.10 plus 10.20 plus 10.10, which is 30.4 divided by 3. So divide that by 3. It gave us 10.134. This thing mean say e dey continue. Omo, come 10.13 mil. All right, that is the Titre volume. So, or Titre volume value. So your volume is 10.13 mil. Is that okay? Now, having gotten the Titre value, the next thing now is the milli equivalent, right? Because to get the percentage purity, you must get the calculated weight first. They already give you the factor. The factor will be given for this particular practical. If they not give you the factor, you go use the details when they give. I go say teach you how we go take fit get the factor in case they no give una. But most time for this particular experiment, they will always give the factor. Are you getting it? They will always give the factor because they don't want you to go into calculation of factor and whatsoever. Now, if they give you, you dey see two things na dey here when you go use take calculate your milli equivalent. Two information. Na these two information you go use. If they na only one of these two they will give to you. If they give you this one, all you need to do, they go give you the atomic mass of iron, give you the atomic mass of sulfur, give you the atomic mass of oxygen, the atomic mass of what? Hydrogen. Are you getting it? When you calculate, you dey see 10 here. I told you initially, 10 go divide 10 from here, 10 go divide 10 from here. So this thing now go come turn to FeSO4.7H2O to give us, instead of 10,000 mil, because of this 10 cancel this 10, it will now be what? 1,000 mil. See, generally, anything when they give you for here, calculator. But most time, now this one they will give you. I just dey use sense, they tell you, say in case now this one they will give you the amount of iron, sulfur, oxygen. You just add the atomic masses together. For instance, what's the atomic mass of I think that particular question they gave the atomic mass of iron. Sulfur is 32, oxygen is 16. When you add everything together, hydrogen is 1, then this one is 1. Iron, I think, is 56 also. All right? It will give you this 278.0 gram of whatever. But most time, this one they will give you. They will give note 278.0 gram of iron sulfate heptahydrate is 1,000 mil of 0.2 molar KMnO4. So now this now you go come carry, go solve for your milli equivalent. How you go use take carry am? Take note. They give you as 278 point what? 0 gram ferrous sulfate heptahydrate will give una how many? 1,000 mil 0.2 molar KMnO4. But I tell una say, listen o, 0.2 molar KMnO4. I tell una say, pay attention to wetin you use for the titration. Wetin you use not be 0.2. Wetin you use na 0.02. So it means this 0.2 we go have to convert am. Are you getting it? This 0.2 we go have to convert because they tell you 0.2 KMnO4. They say A is a potassium solution of potassium permanganate. Potassium permanganate is KMnO4. Are you getting it? So potassium permanganate now get this mass of 0.02. So this 0.2 potassium permanganate, you have to convert it to 0.02. Is that okay? Exactly. So we'll come here now. How would they do that one? I tell you, say first, your meal must break down to 1 meal. So we will break this one down to 1 meal by dividing both sides by what? 1,000. You must not divide this one. As you divide this one, you divide this side, but you must not divide two of them at once. So this one cancel this. When this one divide this will give us 0.278 gram ferrous sulfate heptahydrate will give us 1 mil 0.2 molar KMnO4. We don't get 1 mil. But I tell you now, say our milli equivalent na 1 mil of the concentration of that. That means the mass of ferrous sulfate that will react with 1 mil of the concentration given. The concentration given na wetin, my dear student? Na 0. The concentration given na 0.02 molar. All right, we have 278 divided by 1,000. Okay, 0.27. So we go convert this 0.2 to 0.02 by dividing both sides by what? By 10. So here we divide that by 10. Here we will divide that by 10. So when this cancels this will give us 0.0278 gram ferrous sulfate heptahydrate will be 1 mil 0.02 molar KMNO4. Are you getting it now? So we don't convert them because now wetin milli equivalent mean? 1 mil the concentration of what is given, which is 1 mil concentration of KMNO4 in this case. KMNO4 is 0.02. So 1 mil. What mass of this react with 1 mil of this? So this value you have here is your milli equivalent. So we can come here and say milli equivalent is 0.0278 gram. Because as you divide here by 10, you also divide here by 10. Right? That's our milli equivalent. So for us to calculate the percentage purity, first, I turn and say we must calculate the calculated weight. Expected weight they already give you. The weight of KMNO4 when we expect from 10 mil. 10 mil supposed to contain 0.5 gram. That is the weight. But now we won't use potassium permanganate to really know the real weight. Now potassium permanganate now we won't use now to know the real weight when really dey inside this 10 mil. Whether e dey up to 0.5. Now wetin we dey try know. Are you getting it? So how do we get the calculated weight, my dear student? We say calculated weight. Can you remember? Calculated weight is what? Milli equivalent times Titre value times the factor. Is that okay? Milli equivalent times Titre value times the factor. Is that okay? Your milli equivalent na how many? Your milli equivalent na wetin we don calculate here, 0.0278 gram. So you come here and say 0.0278 times, what is your Titre value? Titre value na the average when you calculate here. Are you getting it? That is your Titre value, which is 10.13 times the factor. The factor was given in the question from beginning. But if the factor is not given, we go still fit calculate am based on wetin I don teach una. Everything wey we dey do for this practical na just this thing here when dey here. All this thing, once you know the factor, all the formula still remains the same. So any question wey dem throw give you, the first thing na to look for the things for the question, then break this equation when wherever equation wey dem give you until you get that fact, until you get the milli equivalent. With the milli equivalent, you can now calculate every other thing, which is 0.343 in this case. So your factor is 0.343. Now, why do you need factor? You need factor because they tell you, say, this chemical form when you dey use, e no really do it, e no really pure, but you wan use am take get ferrous sulfate. So for us to correct the KMNO4, we now use this factor to correct and say, okay, now this factor now dey correct any abnormality, any witchcraft, any spirit of forgetfulness in KMNO4. Now this factor will take the correct am. Do you get it now? So that is the reason why we have the factor here. Now, when you do the calculated weight, what will it give to us? That give us 0.0278 times 10.13 times 0.343, which gave us 0.096 gram. So these are calculated weight. Now, what was the expected weight? Expected weight is 0.5 gram. Calculated weight, what did we get? 0.096. Now, my answer is dependent on my Titre value. If my Titre value na like 20, the answer go change because wetin we get here go come change to times 20, which will give us 0.19. You understand wetin I dey try talk? So e no mean say I get that answer, you must get that answer too. I'm just trying to tell you that the answer is mostly this one go remain the same. This one go remain the same. Any factor when they give to you is everybody will have the same factor, but your Titre value will be different from everybody's own. So your answer will be different. But the most important thing is follow the steps. Now you've gotten the calculated weight. What will be the percentage purity? calculated weight, expected weight times 100%. What is calculated weight? 0.096. That is very small. Expected weight is how many? I don't understand the expected weight. See am here. Because they say, now this put solution A in the burette provided and titrate against 10 ml of solution B. What is solution B? Solution B is ferrous sulfate. They give you 10 ml. The 10 ml is 0.5 gram. But what we calculate for ferrous sulfate from here, calculated weight is 0.09. So expected weight when we suppose get na 0.5, but we get only 0.096. It means say, impurity full this thing because you suppose get 0.5, now you dey get 0.09. So times 100%. So our percentage purity would be equals to 0.096 divided by 0.5 times 100%, which is 19.2% weight by weight. Now, if they give you any specification for BP, they say, okay, BP said the normal rate is supposed to be 56 to this to 100%, 56 to 100 or 56 to 101. What can you comment about this purity? It means that something is impure because what you get na 19.2 and BP say it is what 56 point something, so it is impure. Are you getting it? But they no answer question, but it's a question that may come out. Then the next one, they may now ask you, what type of reaction does A and B undergo? Redox reaction, of course. This is a redox titration. So it's a redox reaction. Why is sample B prepared in acidified condition? Sample B is what? Ferrous sulfate. Why do we prepare ferrous sulfate in acidified condition? It was stated there. Is for acidification generally. It provides the hydrogen ion necessary for the reaction mechanism and prevents the precipitation of ferrous ion as ferrous hydroxide. Are you getting it? It ensures KMnO4 is reduced to nearly colorless, which is pale, providing a clear self-indicating endpoint, pale pink color. That is the reason why everything was prepared in what? In acidified solution. Now, we say sulfuric acid is typically used for the acidification. That is what is used. H2SO4 is what is used. You don't use hydrochloric acid. Are you getting it? Why? Because KMnO4 can oxidize chlorine to chloride ion to chlorine molecule, leading to inaccurate result. What they are trying to tell you is that what is used for the acidification is H2SO4 and not HCl. All right? So that is that. The next question is the precaution. Which precaution you take? What are the precautions necessary to get accurate result in this experiment? It's a very simple something. All the precaution when you take, you should write it out. The sulfuric acid, you should use fume cupboard. Are you getting it? So that it will not you will not inhale it and become irritant. Ensure the the acidic medium is sulfuric acid, not hydrochloric acid. We've said that to prevent oxidation of chloride ion to what? Chlorine molecule. No indicator is needed for this experiment. It's a precaution because why? KMnO4 acts as its own indicator. It's this thing. Then the endpoint. Also ensure that the first permanent pink color is the endpoint. Do not overestimate. Perform the experiment at room temperature. Heating can cause the composition of KMnO4. Use clean burette. Ensure you do triplicate reading. Then correct burette reading. Ensure that there is no air bubble. All those ones, they are what? They are precautions that we are taking for this experiment. Is that okay? Now, how about a situation where you don't know how to calculate the factor was not given to you? Now, how about a situation where the factor was not given to you? Let me see what you should do in that case. But most time, that factor will always be given to you. If the factor is not given to you, my dear student, you'll be given something like this. But most time it's always given. For this particular one, it's always given for this experiment. But if it is not given, you'll be given something like this. Um, they will say it is oxalate. You use oxalic acid to standardize KMNO4. So before the all this initial gragra, before all this initial gragra, in case they will not give you the factor, they could first give you one experiment. Are you getting it? They could first say, okay, weigh out accurately, uh, or they will say pipette 10 mil of oxalic acid or something. Are you getting it? Listen, oh, I dey try bring something when we say e no dey wetin we dey do here. Just listen. I say in a situation where they no give you the factor for this particular one, but most times I have that conviction that for this one the factor is always given. But how about if the factor is not given? It's a very simple something. This is what you do. They go say, okay, pipette so amount of oxalic acid. Eh? They will give you the amount of oxalic acid you should prepare. Are you getting it? For instance, they may say, okay, pipette 10 mil oxalic acid, for instance, which equal 0.06 gram of oxalic acid, which equals 0.06 gram. They may just give something like that of oxalic acid and titrate with 0.02 molar KMNO4 and titrate with 0.02 molar KMNO4 and titrate with what? 0.02 molar KMNO4. Like they will give you this information, you go see am for the question. The amount of oxalic acid to pipette, its amount in mass, this one is for the oxalic acid. Then the concentration of the KMNO4 will also be provided in case they don't give you the factor. They will not say calculate the factor. But then, before that, they will come give you equation like this. They could say 126.06 note 7 gram. This is oxalic acid dihydrate. 2H2O. We give equals 2000 mil 2000 mil of 0 point, how do I want to put it now? How do I want to put it? Whichever way, mil of KMNO4. Anything they give to you here, just know say they will give you something like this. If they don't give you, I'm trying to tell you, if they don't give you the factor, they will give you something like this. What your eye should be going after is the amount of KMNO4 given, the weight of oxalic acid. So you need to calculate your milli equivalent in this case. How do you calculate your milli equivalent? We say, first of all, you break this one down to what? 1 mil by dividing both sides by how many? 2000. This will convert here to 1 mil. 0.2 molar KMNO4. This is molar, big M. So you have 126.06 divided by 2000. That will give us 0.06303 of this gram of this to give us this. Now, remember that we must break it down to the mole of the concentration of KMNO4, which is 0.02. So I go divide this one 2 by 10 so that this one go fit go 0.02. which will give us 0.006303 gram H2C2O4 2H2O 1 mil 0.02 molar KMNO4. See now, this one na be our milli equivalent for the standardization of KMNO4. So that first, this one when they do now, just to get the factor for KMNO4. It's called standardization of KMNO4. Now to get the factor, now be this first one. In case they don't give you the factor, they will give you this one first. Say use this one to get your factor first. So this one when they do now, the first thing when you go do, in case they don't give factor, they get your factor. Now what will be the formula for factor? Factor now wetin? Standard weight or expected weight, you can put expected weight or standard weight or weight of standard solution, weight of solution, anyhow you want put am, all over milli equivalent times your Titre volume. So in that case, now your factor will be equals to, I tell you they go always give you the mass of oxalic acid used. Are you getting it? They will say 10 mil of oxalic acid, which is equivalent to maybe something like this, 0.06. I'm just giving this one as hypothetical. So they go always give this one 0.06 divided by, what will be our milli equivalent? We'll calculate 0.0063.006303 times your volume. They will still give you the Titre volume. They will still give you the Titre volume of oxalic acid. I mean of whatever you use, the Titre volume, they will still give unto you. Say if the Titre volume for KMNO4 is so, Titre volume for KMNO4 rather, they'll give you the Titre volume for KMNO4. When they give you the Titre value for KMNO4, let us say they may say 10 mil KMNO4, 10 mil. Anyone they give to you, you just put it there. So when you now calculate, by so doing, you'll be able to get the factor, which will now be, in this case, 0.06, 0.006303 times 10, which is equals to approximately 0.951. In this case now, our factor is 0.951. It does not have any unit. You get that now. So the same thing when I do for that first EDTA, when I first calculate the factor using the information given to first calculate the factors. Now this factor now you can use to calculate for the ferrous sulfate that will be given. Is that okay? So, but most cases, forget about this particular one. I'm just saying in case, so in case they no give factor, but most kind they give factor. If they give factor, just go straight and do this one and get your answer direct. All right. Then another thing you should also know again, I think titration on be this mumu thing, aspirin, assay of aspirin, that thing, go and know it. I don't do practical on that one before. The assay of aspirin, acetylsalicylic acid, which is back titration. Are you getting it? Back titration. What is generic name for acetylsalicylic acid is that? Are you getting it? You should be able to know all those things. You should know back titration, blank titration, and the rest. So generic name of acetylsalicylic acid is aspirin, and so on. So you have your past question, go through them, then follow this step. Any experiment that is given to you with this, even if it's a gentlementary, with this, you should be able to attempt. You must not get everything correct, but just attempt to. All right. Fish the most important things out. Anything when they give you, once they give you this thing here, this equation, know say this 1000 must go to how many mil? 1 mil. Then this 0.2 of whatever they give to you here, anything they give to you, if now anyone, just go straight to the question. See the amount when they use for that question. Convert this one when you get to that amount by dividing most cases. Are you getting it? Once you get and you don't get your milli equivalent, the next thing are calculated with or factor. It's just a very straightforward something. You see that you are using need to calculate for factor your milli equivalent. See that you are using your milli equivalent to calculate for factor, or you are using your milli equivalent to get your calculated weight, and you know the formula. Do you get it now? So that is just it.